colleagues and friends, it is a pleasure to be here today. And need to get the slides running. Yes, 50,000 blood samples, that's what we're on to next. Okay, so 45 and up study, 11 years old now. It enables researchers to examine health and disease determinants, causes and outcomes, very rich in data. It's used by over 600 researchers, many publications, and there is rich participant-reported information about their health and social environment, both initially and in progressive follow-up. It's linked to multiple routinely collected data sets. It's much larger than other Australian cohorts, and it currently has a collection of blood samples from about 3,500 participants. That wasn't an accident, but this has in reality been a gleam in the eye of the founders of the 45 and up study ever since before it started. We wanted biospecimens early, but there are a couple of things that got in the way. Inevitably, cost. This is not cheap. Also, there really wasn't anywhere that we had any prospects of being able to afford where those biospecimens could be stored. And if you don't have secure, well-functioning storage, you might as well not collect them. And that's just around the corner, happily. I thought it would be useful just to acknowledge what I consider to be a heroic effort that was taken early on to try and get a biobank. And that was Cancer Council's New South Wales Priority 1 project. This was very much the baby of Andrew Penman, the Chief Executive of the Cancer Council at the time. And the Cancer Council worked with the Sachs Institute to develop a plan for a large, not-for-profit biobank, so the place where the samples could be kept, and then the money needed to collect specimens from every 45 and up study participant willing to give their blood and the additional information that we wanted. The cost of that at that time was estimated at $42 million. So this is not cheap. Probably it may well end up more than 42, but fortunately the bit for the biobank has already been spent by the government. Fundraising by way of a pitch to high net worth people sadly did not yield anything like the hoped for results, and so that effort had to be abandoned. In the lead up to that, a pilot study was done to see how well we would go in collecting this, and you can see there basically the statistics. But it showed that at least a third of 45 and up study participants would be willing to give blood if asked. And that required that we didn't have vampires flying around the city visiting people in their homes. They had to make, a trek somewhere. And quite interestingly, they preferred going to a specially organised clinic that was run for us by the Diabetes Institute in Melbourne, actually, at the time, because they had a lot of experience in doing these things. They preferred to go there than to your friendly neighbourhood pathology collection service. And this is information, obviously, that we can still use, but there will be some more pilot work done if and when we can say, okay, the money's secure, here we go. So there is an opportunity now. Serious discussion about the New South Wales Health Biobank began in late 2012 with a workshop and draft consultation paper. By mid-2013, there was a biobanking implementation steering committee. The locus of control at that point moved to the newly formed New South Wales Health Pathology Group, which I shouldn't say to my surprise, but I was found it a little unexpected that they really thought that was a great idea. They wanted to do it. And not surprisingly, therefore, when you have an organisation like that with the responsibility and the capacity, with the motivation, then it's happened. And thanks to 12 billion from the Health Medical Research Funds that the state has to spend, we now have a biobank big enough, functioning very well, we believe, and about to open. And so that excuse is no longer there, and so it's up to us to take the next step. It is time, in the words of Gough Whitlam, to greatly expand the 45 and up study's value as a research asset by collecting and storing blood from 50,000 people. Well, why 50,000? Well, when you sit down and look at it, it's actually a feasible, again, if you can get the money, target, and it's probably not much less than the maximum we could achieve if we tried to get every 45 and up study participant to give blood. Cohort is now of the order of 240,000 people. When we told you about the fact that we've had a few people pass on since they joined. 33% participation is probably the upper limit, and it is, as I've already indicated, quite sensitive to the collection arrangements, and unless we get those collection arrangements right, we might not achieve that 33%. Is that enough? When you ask that question of an epidemiologist or a biostatistician, they'll immediately say, well, we've got to do a sample size calculation or something like that. And so what I've told you here, for those of you who are mathematically minded, is that with 50,000 people, we could detect relative risks of 1.5. That is a risk increase in some outcome of 50% in the people who had a particular exposure compared with the people who didn't have that exposure, when the outcome, when the exposure, in this case I've said genetic variant, was present in 5% or more of participants, and the health outcome we're interested in was observable in 1% or more. Now, those are largish numbers, but in the area of common abnormalities and common diseases, they're easily achievable. And so with that number, we can do a lot of really interesting work on common diseases and relatively common exposure. And in this case, relatively common genotypes. And if we want to, if we've got a variant that's present in 5% or more of people, then that relative risk can go down to 1.2 or a 20% increase. So it is enough to do a lot of good work. We'd like more, but in reality, we're probably going to find getting 50,000 is easy. To go further than that would be somewhat challenging. So what do the biospecimens add? Robust, accessible, and linked genotype, phenotype data sets, along with lifestyle and environmental data, to help realise the potential of precision medicine for the benefit of our communities. Those are not our words. Those are a quote, direct quote from a paper in the Medical Journal of Australia just a couple of years ago about precision medicine and what we need. So what 45 and up is doing is allowing, with the collection of biospecimens, people whose passion is what is now called precision medicine, which is targeting medicine to the specific individual in ways that ensure that the harmful effects are minimised and the benefit is maximised. And that's what a lot of researchers now want to do, and 45 and up study with biospecimens will make that available. But it will make a whole lot of other stuff available as well. This is not just about precision medicine. And here are some of the questions that we can ask. Thinking of genetics, genomics, changes in our DNA, what they can tell us about health, risk factors and outcomes. We can answer questions about what are the genomic risk factors for common health problems. How do those factors affect the outcome of the health problem? Health services use. How do genomic factors interact with lifestyle? All of that information we've already collected from people. And environmental factors, where people live and what the environment is like where they live. We have the capacity to link in our GPS information And so consequently we can locate exactly where people are and what the air pollution is like there if we want. And now we can see how the genetics might interact in that, and who are the susceptible people who, if they live in that environment, are going to suffer so much more. Does knowledge of genomic risk motivate people to change their environmental or behavioural risk profile for important diseases? You've probably heard of a lot of people saying, oh, just we'll test all your genes and tell you what it is, and then you'll be able to live a healthy life. We don't actually have the evidence that works yet. There's quite a few people doing research in that area now, and 45 and up will be able to contribute if and when we're able to have our 50,000 biospecimens. Now, you've possibly heard about proteomics and metabolomics. These are, to some extent, an extension of genomics, but not just an extension of genomics. Proteomics is all about, if you like, the proteome, which is all the proteins that we have in our body. And of course we can't sample all of them by taking blood, but we can sample all of them that circulate in the blood, and that's going to be quite a lot. And it's in reality a lot more efficient and maybe more informative to try and answer the questions that you can answer with genomic data using proteomic data instead. And it just happens that there are researchers, basic biological researchers here in New South Wales, who are at the forefront of using proteomics to do this kind of massive, large volume work. We will have the capacity soon in New South Wales to do something that can only be done in one place in the world at the moment. So this is very accessible potentially for us. Similarly with metabolomics, this is about all of those other chemicals, apart from the big ones, the big proteins and the big DNA, that are found in the body. And again, we'll be sampling all of those that have to be circulating at the time. And if we build into the protocol for this new collection, point of care testing, which is what's used now for having a little box beside you which you're on your doctor's bench and say, I'll just take a blood sample and we'll see how this is going or that's going. Put the blood in, a few drops, and bing, out on the printout or on the screen comes the result. Now that can be put up to a sophisticated level so that we can ensure that when people first get information, all of this metabolomic information could be there and available. And then, of course, if you want to take it seriously and put it through high throughput, high volume mass spectrometry, then you can test whole lots of chemicals all at once and have them coming out and usable for research. This is where we are in technology, and 45 and up can make use of that technology. So what are the potential outcomes? Well, the 45 and up study data as they now is complemented by genomic, proteomic and metabolomic data, and unique population level resource that enables examination of the impact and interactions between human genomes, proteomes, metabolomes, environment and lifestyle in determining health and health service use. This will be a unique source of information, except, and I'll come to the except in a minute, understanding of the best places to intervene at individual as well as population level, and over time the potential to reduce health costs through innovations in prevention, diagnosis earlier and more precise treatment. That's where the precision medicine comes in. It increases the efficiency and timeliness of relevance of health research and is available to all researchers that can be used across the health and biomedical research continuum. Those of you who are new here may not know that 45 and up is available to any bona fide researcher. This is not locked up and belong to a particular group of researchers. If you want to do research and you've got the capacity to do it, and you've got just a few dollars, then you can get access to 45 and up. Possibly costs you a little bit more if you want to get access to the biospecimen, but of course people who do that research have got lots of money. I'll jump one there. Okay. So, what are some of the key considerations? Which participants should we invite? Well, probably the answer is going to be just about all of them. Are there special aspects of blood collection and analysis and storage that should be considered? What do we need to do to make sure that this collection is going to be the most useful possible? And I would suggest one of those is doing the point of care testing, or at least having a lab do all of that straight away. What other measures should we collect, like blood pressure, abdominal measurement, the microbiome? I won't say more about that. Are there opportunities for national or international collaboration to make best use of this new resource? We can learn somewhat from the UK Biobank, and this is the little exception. I mean, the Brits do have a little bit of a lead on us here, in that they've got 500,000 people who gave blood samples, who have also completed a questionnaire and have also had lots of measurements done. So what we need to do is learn from their experience so that we can do the best possible job with our 50,000. What we've got, of course, is already a very rich body of information that they are still having to collect from their 500,000 in our 250,000. So we are, in that respect, ahead of them. And you can see here some of the things that they collect or have collected as people come through the door, the questionnaires. You'll notice, for example, they collected some interview, cognitive function. Now, I'm sure you're going to hear quite soon that that's a very important area of interest. That is ultimately cognitive failure, dementia. And if you've got good information about that early on, then you're able to tell what the cognitive state was at entry into the study and then be able to see it evolve and change over time. And so that's something we might be wanting to think about collecting from everybody that we get blood samples from. And you can see all the physical measurements that they made there, lots of interesting things. Which ones of those can we fit in? Can we afford it? These are the cycles. This is what we can learn from them and from others. And here are some of the things that they're doing now, or actually as soon as they collected the specimens. And again, these are choices that we can make when we design our study by learning from their experience. I think we can also learn from their experience by seeing how the study is being used. And what I've done is to just list a few of the topics studied in recent papers that based their research on use of the UK Biobank. Tobacco exposure and sleep disturbance. Well, that actually doesn't require biological samples. So quite a lot of what's happening in the UK with the Biobank is not using the Biobank, it's just using the original questionnaires to follow up data. The biological impact of blood pressure associated genetic variants in the, won't go through that one, human vascular smooth muscle. Here's where they're using the genomic data. And what you'll see in this list is quite a few that are using genomic data, but they haven't got around to using the metabolomic data. And there's no sign yet of any proteomic data being used there. Sleep and cognitive performance. That's one that was enabled by the collection of that really good cognitive data by interview rather than simply by pen and paper method. Yep, Don's telling me I've got to hurry up. And so I'll come really to the punchline here, and that is that most of what's happening, apart from the use of the genomic data, is very much like the work that is currently being done by 45 and up study researchers. And I think there's a lesson in this for us, and we need to start working on it now. That is, that we are not going to change that pattern unless we engage with the people with the knowledge and the skills and the understanding in the basic biological world and in the clinical world now, and start to prime them for the use. I think there's an excellent example of where 45 and up has already done that, and that's the Cardiovascular Research Network. And you'll hear some of the results of that kind of research later. And maybe we need to be starting to create more of those kind of multidisciplinary networks around 45 and up now, so that we're ready. And we'll, of course, as we do that, they will support our case for the biobank, because that's what the basic scientists want, what the clinicians want. Here are some of the key issues yet for detailed consideration: ethics and an ethically defensible plan, which includes, do we give people information about their result, particularly if it might be relevant to their health, and if so, how do we do it? The unpredictability of technological progress. Are we going to be gazumped by something 5 years after we've collected, where all you have to do is get people to breathe into something and you've got all the information you wanted, no problem at all, and almost at no cost from a collection point of view? Do we want to recruit a new study population? All of our participants are now 55 years and older. Do we want to get younger people? How do we make sure that the way we store what we collect maximises our capacity to make use of those samples? And ultimately, the $64,000 million question is, where do we get the money to pay for the specimen? Thank you.